So we have all the tools in our toolbox to solve a polynomial. We have all of our factoring techniques. We have our new method of synthetic division. It's called the rational root theorem. It's P over Q. That's another method. And then we're going to see all types of solutions. So once again, whole numbers, fractions, which are rational roots, irrational roots, imaginary solutions. All right, I think we know all that. So let's just factor these. So what does this say? For the following polynomials, find the degree of the zeros, the multiplicity, and write the polynomial in factored form. We'll just do the hard ones. So, I mean, that one's not very hard, but let's pull out a greatest common factor. That's very important to remember that if we're factoring, that's always what we start with. So we know that's 3x, right? So then that would be no, it wouldn't. It would be x squared, divide by 3x, divide by 3x. It would be x squared plus 4. Now remember, a quadratic that's two perfect square roots has to have a subtraction sign. So this is as factored as it gets. If we're finding the solutions, is that what it asks for? Find the zeros, find the solutions. We're going to set it equal to 0 and solve. So we'll set 3x equal to 0, x squared plus 4 equal to 0, and solve for x. So we'll divide by 3. X equals 0, and it has multiplicity of 1 since it happened one time. Subtract 4. X squared equals negative 4, square root. When solving by square roots, we need our plus and minus. We know that. What is the square root of negative 4? 2i. Circle it. So we have two imaginary solutions and one real solution. We should have three solutions. We do. So if it wanted us to factor it, now this is kind of unique. So if it wants us to factor it, does it want complex factors? Complex mean any type of factor. If so, then we can actually write this in factored form, even though it's a little weird. It's not a form that we could find by any original factoring technique. But if we solve something, think about it. If we have solutions, we can factor something, which this was as factored as it gets, to be linear and quadratic factors. That's as factored as it gets if that's your instructions. But if they say factor it completely, then we need to use our solutions to factor. So watch. We have this factor, which is our 0. So let's write 3x. We definitely have that factor. And then it's like, how do you factor x squared plus 4? We said it didn't factor, which is accurate, but if you have solutions, you can work backwards to the technically factors. So let's split this up. We have x equals 2i, x equals negative 2i, and now we'll factor it. So we'll work backwards. We did this 2 lessons ago where we worked backwards. Subtract 2i a couple lessons ago. So x minus 2i equals 0 would technically be a factor if 2i is a solution. Add 2i, add 2i. So then we have an x plus 2i equals 0. If negative 2i is a solution, it makes sense that we could say, I guess, that x plus 2i is a factor. So then we would write it, we had an x minus 2i and an x plus 2i. So that's the question is, did they want us to factor it to linear and irreducible quadratics, or did they want us to factor it completely, period, end of story? And once again, if they do want you to factor it completely, period, end of story, you would write the complex factors. You would find the solutions and then work backwards. So just little things to note. All right, let's just look at this one if you don't mind. It's two perfect square roots with subtraction. So we square root, square root. Don't we get an x squared and a 4? And we learned the trick in 1010. What are our signs? Plus and minus. Then from there, does it factor any further? It's two perfect square roots, but it has addition. So no, it's two perfect square roots with subtraction, isn't it? So that factors again. If we square root this, we get x. Square root this, we get 2. So we'll write x and 2, and then we just saw it. It's conjugate signs. So if they want quadratic, irreducible, quadratic, and linear factors, we would be done. That's factored. But let's now find the solutions. X squared plus 4 equals 0. X plus 2 equals 0. X minus 2 equals 0. So we get x equals negative 2. X equals 2. And then we just barely did this exact one, right? Oh, wait, did we or no? Yeah, right here. We already solved it. So I'm just going to write it. We got x is equal to plus and minus 2i. So those would be our solutions. There are 4 solutions. We should have 4. We do. Now, if they say factor this completely, and if they say factor this to be complex factors, let's work backwards. So what would we have here? We just did it. We would have an x Anyone, anyone? X minus 2i and x plus 2i. We just did it a second ago. That's why I'm not wasting your time showing you the same thing you just saw. Then we have our x plus 2, and we have our x minus 2. So this would be factored completely. Okay, good stuff. All right, let's just start. Here we go. So look at this problem. They actually like these on the test. Out of, there's always around 3 of these solving ones on the test. Find all of the zeros and state their multiplicities. So we don't know how to factor anything with a power of 5 and with that many terms. So we're going to do P over Q method. We're going to do the rational root theorem. Remember, P is the constant, Q is the leading term. So let's list out factors of 12. We list out factors of P. Plus and minus 1, plus and minus 12. Things that multiply to be 12. Plus and minus 2, oh dear, there's a lot. Plus and minus 6, plus and minus 3, plus and minus 4. Are those what multiply to be 12? Q, factors of 1 are obviously plus and minus 1. Now we know we're doing P divided by Q. So it's just going to be all of these, isn't it? Because they're divided by 1. So I'm just going to personally go like this and say, okay, so I know my P over Q's divide to be that. Now we just have to start testing. There really is not a way to, without a graphing calculator, get a hint on, well, where should I start? So let's just start with positive 1. 1, negative 3, 3, negative 5. Uh-oh, isn't there a 0x missing? 0, 12. I'm going to check that I didn't mess up any signs or anything before I move forward. Okay, check with me at the end if the remainder is 0, and if so, cool, we'll talk, and if not, we'll move on and test negative 1. I'm getting a remainder not of 0, but I do mess up. Anyone else? Remainder is not 0. I don't care what it is. I could see it wasn't 0, so I just was like, nope. Okay, then let's try negative 1. Just take some dedication on these sometimes. Okay, I'll check with you back at the end. Are you guys getting that negative 1 worked? Yeah. X equals negative 1. I'm going to make my bucket of solutions. Now we know there are 5 solutions. The fundamental theorem of algebra, that's what it's called, says the highest power is the number of solutions you get. The fundamental theorem of algebra. All right, so now from here, we're going to write our new polynomial and see what we're looking at to see if we can finish by factoring. We started with the power of 5, remember, back here, and we've divided it down just one time. So this would be x to the 4th. Minus 4x cubed plus 7x squared minus 12x plus 12. Wouldn't you agree we still have never learned a factoring technique for 1, 2, 3, 4, 5 terms? So we're gonna keep testing. Now here's where you have to make a choice. It's a personal choice. Should we try negative 1 again in case it's multiplicity of 2? Or would you rather move on and start testing 12, 2, 6, 3, and 4? What do you guys want me to do? Test negative 1 again or move on? Should we test it again right now and just get her done and we'll see if it's multiplicity of 2. If we get a remainder of 0, it must have been multiplicity of 2. If we get a remainder that's not 0, then it only happened once. Make sure you're using the new coefficients. Never go back to the original coefficients once you find one that works. You're trying to get it smaller and smaller powered. Every time you find one, you'll now be a power lower. We'll check back at the end. I'm not getting that it works. Are you? Okay, well, it wasn't multiplicity of 2 then. I like that didn't happen because that happened a lot last time. Okay, so it's not negative 1. All right, let's move on. I'm going to try 2 next, just for fun. Make sure you're using the new coefficients still. 1, negative 4, 7, negative 12, and 12. Check back in with me once you've tested 2. I'm getting a remainder of 0. And if you're like, wow, how'd you know that? I really just was like, I haven't done this. This is the first time I've taught this with this problem. But I just wanted to test smaller numbers than 12, you know? So I moved on to the next smallest number after 1. Okay, x equals 2 works. Now we used to be at power of 4. We've now found one that works. Dividing it down 1 power, so this is x cubed. X cubed minus 2x squared plus 3x minus 6 equals 0. From here you would say, okay, if there's 4 terms, let's try grouping, factoring by grouping. But if grouping doesn't work, we just got to keep testing values. Let's try grouping and hope it works because it's so much easier if it does. Pull out the GCF x squared. Left is x minus 2. Pull out a GCF of positive 3. Well, good. This is great. It's working. I'm not done, but it's working because inside the parentheses is the same. So I pull out x minus 2. Left is x squared plus 3. We know our goal is to get this down to linear and quadratic factors because we can always finish a quadratic. We can always finish something linear. So now here are our linear and quadratic factors. If we're solving, let's set it equal to 0 and solve. Use algebra. So I'm getting x equals positive 2. Subtract 3. X squared equals negative 3. Square root it. X is equal to plus and minus. What does the square root of negative 3 become? I roots of 3. A very common error is people will say 3i. The 3 doesn't get to leave the radical because there's not 2 of them. So it's I roots of 3. Are we all okay out there? Okay, so let's go add those to our solution set. X equals 2 already had happened once. We got it again, so say multiplicity of 2. Then we just got x equals plus and minus I roots of 3. It said find all the zeros and state their multiplicities. So we have found them. We've even found the imaginary zeros. Factor into linear and irreducible quadratics. So they don't want imaginary factors. They want you to just write the quadratic part that didn't factor. So that's almost easier. So let's see. If we had x equals negative 1, we must have had an x plus 1 factor, correct? And if x equals 2, we must have had an x minus 2 factor, and we know it happened twice. Then they didn't want us to do the imaginary factorization, so they just want us to write the quadratic that then created those solutions, which was x squared plus 3. So now we've answered all their questions in the box. We've stated the zeros, we've written their multiplicity, and then we've also factored this to be linear and irreducible quadratics. If you were to get to a test and you were to start testing and you have this list and you test every single one of them and none of them work, it's a very good hint to you, as in if you're solving. If they just said, which of these are actual rational roots, we know it's very possible that none could work. If they're asking you to solve, it's possible to solve. That means, I've tested all these. None of them have a remainder of 0. Well, what if that happened? Then you messed up. You probably forgot to fill in a 0 somewhere. Do you guys see what I'm saying? So you could go back and be like, oh yeah, I remember her saying, oh yeah, if I forget to fill in a 0, it's going to throw everything off. Okay, moving on to the next problem. All right, number 1, I'm laughing at them because I don't feel like that's helpful to me. It says, given that x equals 2i is a 0, find the remaining zeros. That's not helpful. We can't do synthetic division with imaginary. So I'm like, okay. I guess the only way that's helpful for me is in the end. If I don't have a 2i, I know I went wrong. Do you guys see what I'm saying? All right, and let's go ahead and do it then. There are 1, 2, 3, 4, 5 terms, so we can't do any method of factoring that we know of except p over q. Factors of 24. Let's strap in. That's a lot of them, kind of. 1 and 24. Is it 4 and 6? And then 2 and 12? That multiplies to be 24. Now, yes, if you're thinking, oh, and I'm missing, you're saying 3 and 8? Ay. That's a lot. All right, luckily our q is a leading coefficient of 1. So I'm just going to write p divided by q is those because we're taking the p's divided by 1. Okay, we just got to get dedicated here. Let's try positive 1 and check back in together. 1, -1, -2, -4, -24. I'm going to check 4, 3, 2, 1, constant. Okay. I could have messed up, but I'm getting the remainders not 0 when I do 1. Are you guys getting a remainder of not 0? Okay, then move on. Let's try -1. I'm getting that the remainder is not 0 for -1. Okay, I'm personally going to move on to, I don't want to do 24. I'm hoping that something else works. So I'm going to go to the next biggest number, which is 2. It's just a personal choice. It doesn't matter. I'm literally just shooting at the wind like you guys. Okay. I'm going to try +2. I'm getting the remainders not 0. But once again, that's why I'm hoping that we can all do it so that if I mess up, that we can catch it. I'll give you a second to finish 2. Checking 2.
So does this mean that 6 would work? Like if we had 4 left over here, and 4 times 6 is 24, and then 8 right here. And so that would be a 3. 3 times 2 is 6.
So you're saying maybe we should try 6 next? Okay, sure. Let's try 6 next. Why not? Let's see. She's kind of noticing like, oh, maybe 6 is going to work.
-2 works.
Oh, -2 works? Okay, I wonder if 6 will work too. Because we're going to probably, okay, if -2 works, I'll just do that then. If we know for a fact it works, just because you got ahead of us and did that, thank you for helping us all out on that. -24. You're right. I'm getting also a remainder of 0 with -2. So we know we're going to have how many solutions total based on the fundamental theorem of algebra, everyone? Good. 4 solutions. The highest power is 4. Yes. X equals -2. I'm going to write the new polynomial. We went from a power of 4. We've only divided it down once for it to work. It's only divided down once, giving us now x cubed minus 3x squared plus 4x minus 12. Man, they're being really good to us, creating these nice problems that a lot of the grouping ones are working out at this point. There's 4 terms and grouping's working. Most textbooks, a lot of times, the problems they make up, they don't have, it doesn't group, the grouping doesn't work here, so we have to keep testing. But it's nice that they've created such nice problems. Props to UVU. So pull out our x minus 3, left is x squared plus 4. There's our linear and irreducible quadratic factors. If we're just solving, let's just finish. X minus 3 equals 0, x squared plus 4 equals 0. We're going to solve. X equals 3, subtract 4. X squared equals -4, square root it. So x is equal to plus and minus 2i. All right, let's go add it to our solution set. X equals 3 and x equals plus and minus 2i. Is set of number 1. This is a 0. Find the remaining zeros. We have 4 of them, which we should, so we're good. And then it says factor to linear and irreducible quadratic factors again. So if -2 was the solution, we know x plus 2 was the factor. If x equaled 3, x minus 3 is the factor. And then it doesn't want your imaginary factors. It wants the quadratic before it was solved, which was x squared plus 4. That's a quadratic that's considered an irreducible quadratic, meaning it doesn't factor naturally with real numbers. Okay, good. Good, good, good. So really not much different today from last time. Let's look at another one. Okay. So now here is something you got to think about, okay? So if you have a quadratic let me just state this out loud here. Let me make up a problem that works. If you have a quadratic that factors, isn't it true that you're going to have whole number or fractional solutions, everyone? Yeah? That's by definition, if it factors, for sure you're going to have fraction and whole number solutions. Think about it. That would be like x. This isn't the right factors. I'm just making up new factors. You know what I mean? Do you guys see what I'm saying? It's going to be if it factors fraction and whole number solutions. Okay, so if it doesn't factor, you're going to do the quadratic formula, for example. So we would do it x equals negative b plus and minus the square root of b squared minus 4ac all over 2a. So now listen, we get solutions that look like this when dealing with the quadratic formula. For example, 1 plus and minus root 3, that would be an example. And then another one would be, well, we could get imaginary solutions like 2 plus and minus 6i, okay? So think about it. Look, by definition then, it's not going to happen the plus without the minus. Do you guys agree? It's built into the quadratic formula. So there is no way you're just going to get x equals 1 plus root 3. It is not possible. You would have also had to get x equals 1 minus root 3. Do you guys agree? Because it's built into the quadratic formula. Like there's no plus without the minus there. Same thing here. If you have x equals 2 plus 6i, that's not ever just a solution by itself. That's not even possible. You would also have x equals 2 minus 6i. So that's what this brings up right now. This says if you have irrational solutions, their conjugates have to be solutions. A conjugate is a change of sign in the middle, only in the middle. See, these are called conjugates. If an irrational solution is a solution, its conjugate must also be a solution. It's just not possible without it. If they ask why, you'd say because it's built into the quadratic formula, a plus and minus. Same thing here. It says if you have an imaginary solution, its conjugate must also be a solution. So remember, a conjugate is only a change of sign in the middle. Don't change both signs, only a change of sign in the middle. So that's right here coming up. So notice all of these have conjugate solutions. See, I've done plus and minus in all of them. Okay, all right, cool. So let's read this problem. It says p of x has solutions x equals 2 and x equals 1 plus root 3. What are the other solutions? Anyone? 1 minus square root of 3. You're right. There's no way you just had a 1 plus root 3. That's not even possible. Its conjugate has to be a root because it's an irrational solution, which came from the quadratic formula. Now, a lot of students will accidentally say x equals negative 2. Now, is it possible that negative 2 is a solution? Yeah, I guess. But is it guaranteed? No. Like, the quadratic formula doesn't create whole number solutions unless you're using it when you really shouldn't be. You know what I mean? So you can't assume negative 2 is a solution. You only can do that with irrational solutions or imaginary solutions. Okay, so same thing here. Look, read it. It says p of x has solutions negative a half, 4i, root 7, and 2 minus 3i. What are the other solutions? So you would say x equals negative 4i, x equals negative square root of 7, and x equals 2 plus 3i. Yes, good. Imaginary solutions and irrational solutions have to come in conjugate pairs. All right, so now we're just going to be building polynomials. So let's lock in on this, everyone. Okay, so let's read this. It wants you to create a polynomial with this information. So it says f is degree 5. So let's make note in our head. We need to have 5 solutions. True? If it's degree 5. All right, so they gave us x equals 6. So I'm going to rewrite it so I have some room. X equals I. So what does x also need to equal? If they're giving you I, what does it have to for sure also equal even though they didn't list it? Negative I. And then x equals 1 minus 3i. We have to know, oh, but they didn't list it because they're seeing if I know imaginary solutions have to come in conjugate pairs. So that would mean 1 plus 3i is also a solution. Now let's count. 1, 2, 3, 4, 5 solutions. So you're like, okay, I've met that requirement and that requirement. Okay, so then from there it says, okay, so if it wants a polynomial, these are solutions. We work backwards to find the factors. So we're going to minus 6. X minus 6 equals 0. Subtract I. x minus I equals 0. Add I. X plus I equals 0. I don't know why people think this is so complicated, complex. Guys, watch the next one. I'm like, what? Why is this so hard for people? Look, get this side equal to 0. This is like the most basic algebra we've done all year. How do you get 1 to the other side? Minus 1. So we have x minus 1 equals negative 3i. You with me? How do we get this side equal to 0? We then add 3i. So we have an x minus 1 plus 3i equals 0. It's like incredible because so many kids cannot do that. They cannot get the factor. I'm like, just use algebra. Stop trying to do it in your head. Okay, so right here, won't we minus 1, my friends? And also, let's hit 2 birds with 1 stone. Won't we also minus 3i? So we're going to have an x, a minus 1, and a minus 3i, and now equals 0. Before they were split apart and set equal to 0, they used to be multiplied together. So write x minus 6, x minus I, x plus I, x minus 1 plus 3i, x minus 1 minus 3i. So we're going to write y equals, or f of x equals. Okay, now they never said we had to distribute this, so wouldn't you agree leaving it in factored form is going to be the easiest choice here? Instead of distributing this thing out, it would be a nightmare to distribute it out. Okay, so let's leave it. Now let's answer the last piece. It says, okay, so let's think together here. As x goes to infinity, so if we have a chart, an xy chart, or sorry, not an xy chart, a graph, as x goes that way, they're telling you f of x, the y values go up. Now so the thing is it up and up then? Or is it down to up? Well, isn't it x to the 5th? So is it up and up? No, can't be, because up and up would be an even power. So it must be down and up. So let's see here. If something is down and up, should the leading coefficient be positive or negative?
Positive.
Positive. Is it currently positive? Let's look. X times x times x times x times x. It is positive, so we're good. What if we needed it to be negative? Like, what if it would have been up and down? Then we would have thrown a negative in front, right? You can put a constant in front.
Nothing that says as it goes to negative infinity, it goes to positive.
Oh, I did positive infinity. Okay. See, it felt too easy. You're right. It wasn't, I drew it to positive infinity. You're saying that actually it says as x goes to negative infinity. I should have been doing that. You're right. Okay, well, now it makes more sense of what they were going for here, because I was like, why did they even say that? It didn't change my answer, but okay. So we're actually doing it this way. As x goes to negative infinity, f of x goes to positive infinity. You're right. So it's actually up to down. Oh, isn't that the decreasing over time? So that makes sense. We need to throw a -1 in front. A negative number. Any negative number actually works. Numbers in front don't change solutions, but I'm just going to go -1. So I'll just throw a negative in front. All right. Okay, good. Let's do another one. Okay, the graph touches but does not cross. Okay, let's draw visual aid here. The graph touches but does not cross at 2, 0. So x equals 2. It touches but doesn't cross. Doesn't that mean they're trying to tell us something about that 0? It's multiplicity of at least 2. Could be 4, could be 6. So let's go x equals 2, x equals 2. We'll do the least and then see if we need to do more than that later. Okay. Then it says, and right here it said, find a polynomial of lowest power. So we are going to pick the lowest amount possible too. Okay. Then it said x equals 3i. Well, it doesn't say x equals -3i, and they do one like this on the test, and there's always a kid that then says, okay, those are my solutions. Remember, no, that's not possible. What's the other solution? -3i. All right, we're going to write the polynomial. Those are the solutions. We're trying to write the polynomial. Let's write it in factored form, so we'll -2. So we have x minus 2. -2 again. So we have x minus 2 squared. minus 3i. So we have an x minus 3i. Add 3i. So we have an x plus 3i. Then let's write f of x equals, or it says p of x. So we'll say p of x equals. Now that's just so far. We might have to add in more. They say, as x goes to negative infinity, the function p of x goes to negative infinity. And as x goes to positive infinity, p of x goes to negative infinity. Isn't that end behavior down and down, everyone? Which means our leading coefficient must be negative. So let's go put a negative in front. That was the only thing they told us. So we've met their requirements. Okay, good. All right, they're just getting harder and harder. We're almost finished. This will be our last one like that. And then the last piece is really easy. I wrote myself a note, review this one before teaching it. So we'll see, because I didn't do that one. So let's see here how this goes. You guys can help me out. All right, so it says x equals 2i is a 0. I just think that there was something, I was like, Okay, so x equals 2i is a 0. So we know x equals negative 2i. Oh, okay, well, that's really not hard. So it says, and the point negative 1, 0 is a local min. If it's a local min, wouldn't it be a bottom of a hill? So what do we know about that? That's a solution. Look at it. It's an x-intercept. So don't we have x equals negative 1 with multiplicity of 2, right? Could it be multiplicity of 4? Yeah. Could it be multiplicity of 6? Yeah. But look, they told you right here, your leading term is 17x to the 4th. So you know we should only have 4 solutions, and we do. So let's work backwards. X minus 2i, see I'm subtracting 2i, equals 0. Add 2i. X plus 2i equals 0. I'm adding 1. X plus 1 equals 0. We know that that happens twice. Okay, let's write out it now. Before it was split apart and equal to 0, it used to be multiplied together. So we'll say f of x equals, we had an x minus 2i, an x plus 2i, and an x plus 1, and it happened twice, so squared. Okay, so we've met the 0, we've met the local min. Now we just need to fix our leading term to be that. Ask yourself what it currently is. Isn't it x times x times x squared, everyone? Which is x to the 4th, so what do we need in front? It's that simple, 117. That will not change your solutions. It won't, it won't change your end behavior. It is positive. So yeah, we're good. There we go. Okay. The next part's really easy. It's going to be like, oh, use your intuition. So just a reminder, everyone. Watch. We know the square root of negative 1 calculates to be I, correct? So watch. This is also a mathematical true statement then. If you said, I want to undo the square root, you could square both sides. Root and power cancel out, which would be negative 1 equals I squared. Oh, okay, so mathematically, if you see an I squared, you could choose, if you want, to write it as negative 1. They're equal. Do you guys see what I'm saying? So which one's better, I squared or negative 1? Negative 1 is considered more simplified than I squared. So anytime we see I squared, we need to switch it out for a negative 1. All right, so everybody look here. They just have some complex numbers. That means there's some i's in it. So complex numbers have the form a plus bi, where a is the real part, bi is the imaginary part. They like it written in that order, a plus bi, and in that format. So anyways, it gives us z and w, and it tells us to add them. So you're going to use parentheses no matter what. So that would be 2 plus 3i added to 4i. So then you'd say addition doesn't need any distribution. So now you would have 2 plus 3i plus 4i. And also parentheses can be important, but there's nothing in front here. You can only add real parts to real parts, imaginary parts to imaginary parts. So what is the real part? 2. What's the imaginary part? 7i. It's that simple. It's just like adding up like terms. Really easy. Let's do B. B says multiply them. Use parentheses. 2 plus 3i times 4i. It's a times sign. Now you're going to distribute. This times this is 8i, isn't it? Now watch. This times this, just focus on multiplying the numbers and then multiply the i's together. 3 times 4 is positive 12, isn't it? I times I is I squared, right, my friends? So then from there you would say, oh, this is a times sign. So really this is 8i plus 12 times negative 1. Not adding, it's a times sign. So isn't that just 8i minus 12? 12 times negative 1 is negative 12. So now we're going to write it in the correct order. The real part gets listed first. So you'll say negative 12 plus 8i. Okay, part C. Z squared. There's going to be some sad souls on the test that do this one, and you're going to be thinking, what in the world was I thinking? Z squared would look like this. I'm going to write it over here. 2 plus 3i squared. Do not, I repeat, do not square. That's not how math works. We know that. We're past that point of making that error. That is not mathematically correct. We have no choice but to write 2 plus 3i, 2 plus 3i, and double distribute. Stick with me through this double distribution here. 2 times 2 is 4. 2 times positive 3i is positive 6i. 3i times 2 is another plus 6i. And then this is where a lot of kids will mess it up. Let me show you the common mistake, so hopefully it can stick with you. A lot of kids will go 3i times 3i is plus 9i. But it's not. It's not 9i. What is I times I? I squared. It's 9i squared. Which remember then, what do we have so far? We have 4 plus 12i, don't we? Plus 9i squared. Okay, I squared is better written as negative 1. We have a positive 9 times a negative 1. What is that going to become? Is it a times sign here? Yes, so it's a times sign here. Negative 9. So now we have 4 plus 12i minus 9. Combine real parts with real parts, imaginary with imaginary. So 4 minus 9 is negative 5. And then we have plus 12i. Part D says Z divided by W. Okay, this is something you're going to need to know. You wouldn't know it right off. So 2 plus 3i over 4i. Okay, couple things. It's not considered, like if you said that's my answer, you're writing an answer that's not wrong. It's just not simplified. Here's the thing. It was an adapted norm, I don't know at what point or whatever, to not leave an I in the denominator. They don't consider it pretty. So it's like, we need to give this a makeover. So the only way to give this a makeover is, and the goal of the makeover is to not have an I in the bottom. In the top, they don't care, but on the bottom, they do. So think about it. How are you going to make an I a number? Well, you got to only times by something. So if I times I by a number, like 2, that's not going to fix anything, correct, everyone? I can't just square this. That's not the same value. If you square something, you've doubled it, and you can't just choose to double it. So what do? We multiply by 1. That's allowed. Look, multiply by 1. Now, I'm being dramatic here. Yeah, I'm multiplying by 1, but we got to be more strategic. So if you think about it, isn't I squared a number? I squared is negative 1. We need to make the bottom I squared. So don't we need to be timesing by I? If you do it to the bottom, you're going to do it to the top. Because look, then you're timesing by 1. Isn't I divided by I a 1? So you're not changing the value. You're timesing by a fancy 1 that for your strategy is what you need. Now it's very important to go put parentheses around anything with 2 terms. So now we're going to distribute I through on top. So won't we have a 2i plus 3 what? 3i squared. We're focusing on the top. So then, keep focusing on the top with me. Isn't this negative 1? So won't that become 2i and then a positive 3 times a negative 1? What will that be? Minus 3. So I'm going to write it in the correct order. Well, I'll just leave it for now. Now on bottom, it's one term, so we don't need to distribute. Isn't the bottom just now this? 4i squared? This times this, 4i squared, yeah? Okay, so watch. Kids will write it like this, and then they'll go, oh, these divide out. Well, for one, you can't divide across addition signs, so no, that's not accurate. Okay, so now what do you really have here? That's 4 times I squared. Isn't that really just 4 times negative 1? Which is negative 4. So now you're like, oh, I gave it the makeover that they desired because it doesn't have an I in the bottom. From here, though, they want the answer in A plus BI format. So we're going to split up the top from the bottom. So here we go. We're going to say 2I over negative 4 minus 3 over negative 4 and simplify it. So what's the I part? What number is 2 over negative 4? Negative 1/2 I. 2 and 4 become negative 1/2. Well, 2 divided by negative 4 is negative 1/2. Negative 1/2 I. Now, if that's weirding you out that I pulled the I out instead of putting it on top, it's the same thing. Don't we multiply straight across? So it would go on top. Okay, so we're writing it like that. And then won't it be plus 3/4? And then one last step, A plus BI. So you're going to write 3/4 first minus 1/2 I. So you just have to memorize, oh, why are they asking me to even simplify the dividing thing? Oh yeah, an I on bottom is not considered simplified. Okay. All right, go on to E. Conjugate of Z. You tell me, what's the conjugate of Z? 2 minus 3i. There's a reason they're doing that because that brings us to, oh, never mind. The conjugate of Z. Oh, that's, what the heck? What am I asking? Is that it? A, B, C, D, E, F? Have we done them all? Did I skip one?
The last one. Z times the conjugate of Z.
Why did I not see that? Oh, right there. Z times the conjugate of Z. Okay, so Z was 2 plus 3i, and then its conjugate was 2 minus 3i. Okay, okay. So now from here, we're going to distribute. 2 times 2 is 4. 2 times negative 3i is negative 6i. Positive 3i times 2 is positive 6i. Positive 3i times negative 3i is negative 9i squared. Now look, when you multiply conjugates together, this only happens if it's conjugates. Do you guys see how the middle term is canceling out? That's always going to happen. As long as they're conjugates, a conjugate is only a change of sign in the middle. Okay, the middle term canceled out. So far we have 4 minus 9i squared. Now careful, think advancedly with me. This is a times sign right here. Isn't this negative 9 times negative 1? Which is plus 9. So we have 4 plus 9. Isn't that 13? 13 is what it simplifies to be. If you're dealing with imaginaries and you multiply a conjugate together, the I will go away or you messed it up. It's just going to be a number. All right, we're going to skip. The only one we have to do is they were building you up. See, they were building you up for a problem. So here's what we'll do. We'll just skip all of this, and I'll just show you back. I'm going to stay on this page. I'm going to make my own problem. Okay, so what if they would have had you do 4i, watch, 4i divided by 2 plus 3i. Don't divide across addition signs. The i's don't divide out right there. So it's like, once again, why is this considered simplified? Because there's an I in the denominator. Now listen, it is not going to work the same that you can just times by I over I. This is going to be the common error if this problem's on the test. People are going to times by I over I. Here's why that won't help. Look, on bottom there's 2 terms. So when I distribute, I'll then have a 2i, and then plus 3i squared. This is wrong, so you might as well not write it down. So then we have a 2i minus 3. Did that get rid of the I? No. Okay, so you just made it worse. Like you literally just didn't even do anything. So why is this not working? Because the bottom has two terms. Last time we did it, the bottom was this, and the bottom only has one term. And if the bottom only has one term, you can just times by I. Listen to the rule. If there are two terms, to get rid of I, you have to multiply by the conjugate. Didn't we just see how that made it a number? Do you guys see what I'm saying? So you have to memorize that. Oh, there's two terms. The only way to make that a number is to multiply by the conjugate. So 2 minus 3i, you got to do it to the bottom and to the top. Because then look, you're timesing by 1. 2 minus 3i divided by 2 minus 3i is a 1. Okay, so now we would distribute. That would be 8i minus 12i squared, which is negative 12 times negative 1. Won't that be 8i plus 12? Are you guys seeing how I'm doing that? I'm doing negative 12 times negative 1 because I squared is negative 1. Okay, now on bottom, we would have a 4 minus 3i plus 3i, or sorry, minus 6i plus 6i, so the middle term canceled out, so I'm not going to write it. Then I have a minus 9i squared, which is 4 plus 9, which is 13. See, it got rid of I in the denominator when we multiplied by the conjugate. Now we would split it up. So you would do 8/13 I plus 12/13. See, I just split up the top from the bottom. 8/13 doesn't simplify, 12/13 doesn't simplify. Then we write A plus BI. So 12/13 plus 8/13 I. Okay, so we're not going to do all of these by any means. We're only going to do one, and I'm going to do it just the most important one. So just right in the middle of the paper, let's just do this one. I promise if I don't, you're all going to get to the homework and come be like, what the heck? So let's see this out. What if I asked you to take 3 minus 5i and divide it by 2 plus 7i? They say simplify. You'd say, why isn't this simplified? Oh yeah, because there can't be an I in the denominator. Oh, there's two terms in the denominator, isn't there? So what am I going to be multiplying by? 2 minus 7i. Yeah? And then 2 minus 7i. Because it's a conjugate when there's two terms. You've got to use parentheses around anything with two terms, ever. So now look, this is going to be, the top's going to be kind of a nasty bugger, but let's go for it. 3 times 2 is 6. 3 times negative 7i is negative 21i. Negative 5i times 2 is negative 10i. Negative 5i times negative 7i is positive 35i squared. This is the top. I'm going to focus on the top for a minute if you don't mind. So then I would have a 6 minus 31i. And then isn't this 35 times negative 1? So won't that be negative 35? Once again, guys, look right here. This is a negative 1 and it's a times sign. So I'm saying 35 times negative 1 is negative 35. So I'm getting negative 29 minus 31i. That's my top. Now let's do the bottom. 2 times 2 is 4. Minus 14i plus 14i minus 49i squared. The middle term cancels out because that's what conjugates do. Then we have a 4, and that's negative 49 times negative 1. Isn't that just plus 49 then? A negative times a negative is a positive. 49, 50, 51, 52, 53, divided by 53. So then you'd split up A plus BI. Negative 29 53rds. Oh, it was a minus because it's a negative and then a positive on bottom. So minus 31 53rds I. A plus BI. Now, really, you could technically leave it like that. It's just, it's not, it wouldn't be wrong on a test. It's just, it would never be really written on an ACT that way because complex numbers are written like this, not like this. So I don't really care on the test, but I'm going to probably always do this. Okay, questions? Okay, so we are almost finished. We really are. I just want to remind you, look. So if it said simplify these, let me explain something. I'm thinking. Okay, so we know the square root of negative 1 is I. Remember that, okay? So I'm trying to think here. Let's do this. Okay, so right here, let's simplify this first. What would that be? 5i. Okay, good. And then we're timesing that by 2i, which is 10i squared, isn't it? Which then calculates to be what number? Negative 10. Good. So the difference in this versus this. Let's do this one. So now, wouldn't you agree both are under the square root right now? So it's kind of almost like a parentheses. We're going to multiply those together first. So wouldn't that be just the square? Whoa, it moved. The square root of 100, which is 10. Okay, good. So now look at the difference. It's like, well, this and this almost look exactly the same. So here is the rule. If you ever have a radical and it's split apart, you need to simplify the radical single-handedly first before you multiply it together. Right here, they were already putting it in a multiplication problem together. And so notice our answers aren't the same depending on which way we do it. So it's just a general rule of thumb. If you have radicals that are split apart, you first need to simplify them before you multiply. Do you guys see what I'm saying? Okay, so what's this one going to be? Isn't that just the square root of 9? Which is 3. What's this one? The negative is outside. So we simplify the radical. What would we get? 3i, and there'd be a negative in front. Okay, good. All right, they love these. Okay, they love these on the test. So and they're really easy. So let's look at these. All right, so here's the thing. I is as simplified as it gets. And when it comes to complex numbers, like that's 1i. And then remember, I squared's negative 1. Like negative 1 is considered more simplified. So basically, you're looking to get an answer of 1, negative 1i, or negative I, because these are considered as simplified as they can get. Like nothing can happen. 1 is 1. Negative 1's negative 1. I is I. Negative I is negative I. So look, let's start with I to the 8th power. They're saying, what does this simplify to be? So what you're going to do is, I always recommend starting with I squared. So why? Why am I choosing I squared? Because I know what I squared calculates to be. So let's write I squared and then do parentheses around it. I'm then always going to raise it to a power. This is how I personally do this. There are other ways, but this is how I do it. So I have an I squared and it's raised to a power. What power to get me to 8? 4, because we multiply. So now from here, why is that helpful? Well, because now I can rewrite this as negative 1 to the 4th. So I just strategically pick I squared because then I can change it to negative 1. What is negative 1 to the 4th going to calculate to be? 1. 1 is as simplified as it gets. You can get a 1, a negative 1, an I, or a negative I as an answer. It's going to be one of those. Let's do I to the 304. Always start with I squared. Then say I'm going to raise it to a power. I've got to get as close to 304 as possible, if not dead on. It's multiplication, so you would go to your calculator and divide. 304, does it divide by 2 perfectly? Yes, 152. So now you have negative 1 to the 152 power. If you don't know what that is, you would go to your calculator and go negative 1 raised to the 152, and it gives you that it calculates to be 1. Okay, let's look at I to the 1/17th first. Start with I squared, raised to a power. You're not going to be doing decimals. So if you take 1/17 and divide by 2, it's a decimal. Okay, so just a minute. So let's get as close as possible here. What would be divisible by 2 that's dang close to 1/17? 1/16. Let's try that. So 116 divided by 2 is 58. Okay, so let's put a 58 up here. Now, right now, we currently only have I to the 116th, correct? But we need it to be 117. So just times another I in here, because look, now we have 117 I's, but we can simplify it better. See, this is 116, there's our 117th. But why is this easier to simplify? Because now we have negative 1 to the 58th power times I. What is negative 1 to the 58th power? 1. So we have 1 times I, which is I. You should be getting answer 1, negative 1, I, or negative I as an answer. Those are considered simplified. Okay. So I to the negative 7, this is how I'm going to do it. You could probably think of a different way, but this is what I'm going to do just because it comes to mind right away. I'm going to write this as a positive exponent by flipping the base over a fraction. So I'm going to call it I to the 7th on bottom. So I have 1 divided by, I always start with I squared, and it's raised to what power? It's not going to be divisible by 7, but can't we get to 6? 2 is divisible by 6, yeah? 6 is divisible by 2 is what I should have said. So I'm going to put a 3 here. But then how many am I, why did I write a T? Is that a T or an I? I don't know why I'm writing T. No idea why I'm writing T. I'm supposed to be writing I. I squared. And we need 7 of them. So what do we need to times by? 1 more I. So then you'd say, okay, so what do I have? 1 over negative 1 to the 3rd times I. So that's 1 over, isn't negative 1 to the 3rd negative 1 times I? So then we have 1 over negative I. That's as good as it's going to get. Okay. Okay, you guys will start doing the lesson. It took a little longer than I expected, to be honest. So this is 2.5. Next time I see you is review day.